Hi, welcome everyone. This is case 2 of this project. In this video, we will be learning how to create a simple web app for finding and drawing the shear force and bending moment diagrams of a simple propped cantilever beam with a flexible support. After completing the development of our web app, it looks like this. It takes three input values, namely length, load, and spring stiffness. If we enter the inputs in this input boxes, length, downward vertical load, and spring stiffness, Python in the backend will evaluate the shear force and bending moments using OpenSys library and directly sends them to the front end using a class of matplotlib library called figure canvas AGG. This one here, AGG refers to anti-grain geometry. This is used for rendering high quality vector graphics. The main advantage of using this library is that we no need to save the figures to render them in HTML. We can directly send them to the HTML via template variables. When we have many images to display on the front end, then saving and loading is less efficient compared to sending files using figure canvas AGG. This is the HTML file. This is similar to the one that we saw in case 1. The only difference is that you will see these variables image data BMD, image data SFT instead of file names and file paths in case 1's index file. That's it. Everything else is almost similar to the index file that we have written in case 1, except that of course the input values are different. In case 1 we have taken slopes and intercepts as the inputs, and now we are taking length, load, and spring stiffness as the inputs. Let's look at app.py file. These are the libraries we need. If not installed yet in your machine, please install them using pip install. Along with the Flask, figure canvas AGG, we need two more libraries called IO and base64 to properly encode and display the images. We first import the Flask library and create an instance of Flask class which we name as app. Then we use app root decorator to specify the URL root that this function should handle. In this case, the root is the root URL, namely slash, and we specify that the function should handle both get and post requests. Next, we get the input arguments. After that, we pass this length, load, and spring stiffness to this eval SFT BMD function. In this function, we evaluate the shear force and bending moment and plot them using matplotlib and return the final results and figure handles, which we store them in these variables in app.py. We use these results and figure handles in this page to process them for display in the web page. Let's dive into this eval SFD BMD function and explore what is happening in it in detail. I wrote this eval SFD BMD in eval main.py. I discussed in detail about this finite element implementation in project number 2. Here in project number 2, case 3, I discussed in detail about each and every step involved in finite element modeling and implementation of this propped cantilever beam with spring support. Please take a look for more information. In this project, we are not going into the details of the finite element implementation. Rather, we are going how to convert the finite element implementation into a web app. So we are going to look those aspects in detail. Few changes I have made to the function which I have shown in case 3 of project 2 are: first, I converted that code into a simple function that takes three inputs: length, load, and spring stiffness. Rather, in project 2, I have directly given these values as inputs. Here, these are input arguments to this function. In the end, I plotted SFT and BMD using the OpenSys visualization library. After plotting, I returned the shear force and bending moment values at the fixed end and the shear force and bending moment diagram fixed handles as well. Next, we send these values of shear force, bending moments, and these figure handles to app.py. Here, upon receiving these values and figure handles, this code creates figure canvas objects from the SFD and BMD figures and render them as PNG images using print PNG method. The image is then stored as bytes in a bytes IO buffer. Here the image is then encoded as a base64 strings using this method b64 encode of base64 library. That's it. Now you have all the results and images in the form of strings. You can now render them in the HTML using render template function like this. That's all. Then go to the conda prompt and check whether you are in the right directory or not. Then issue python app.py. Copy this HTTPS address and paste it into any browser. That's it. Our web app is ready. Let's try out some values. I'm giving a 200 length, 50 Newton load, and 2 Newton per meter stiffness value. When we evaluated it, these are the shear force and bending moment diagrams that we have got. At support, we have noticed some 46.99, which is approximately 47 Newton, and 9398.49 bending moment at the fixed support. And at the free end near the flexible support, we noticed 1.5 downward displacement. If you have any questions or need any help, you are always welcome to post them in the course discussion forum, and also you can always email them to elastropy@gmail.com. Happy learning. Thank you.